Hello friends, this is Jahiruddin sir once again. Today we'll be discussing one interesting problem in classical mechanics. We'll find the Lagrangian of that problem. So what we will do? We'll find Lagrangian of a simple problem. Not very simple, of an interesting problem. Well, let's see the problem first. We have a wedge like. We have a wedge. Well, fine, not wedge like. There is a box which is sliding the wedge, and the wedge is not fixed also, means wedge is also sliding. So wedge can slide. So this is wedge. This have a angle theta, mass m, height maybe h, and this box has mass m. So the most interesting part is both the wedge, the mass m can slide through the inclined plane on the wedge, or ramp, whatever you can say, and the wedge having mass m, capital M. This wedge, so this is the wedge, can also slide through the horizontal plane, the ground. There is no friction, no friction anywhere, no friction anywhere. We'll find the Lagrangian. We'll find the Lagrangian of the problem. So you see, you have two things which are in motion, two masses. One is your mass capital M, another is your mass small m. So while both the masses are moving, you need to specify the coordinate very properly. So let's see, let's assign the coordinates first. So we'll make a bigger picture here. Say this is your wedge. So you specify coordinate, so you make it a parallel, I mean perpendicular to the wedge plane. So your this distance, this is say your x2. Say this is as x2. This will be the generalized coordinate of this mass, which will be the distance from at the top of the wedge, parallel distance through the plane of the wedge. And the wedge itself, the position of wedge, this will also need an independent coordinate. So if we say this is my y-axis and this is my x-axis, so this distance is x1. So x1 and x2 are independent and describes the system fully. Well, you have x-axis, you have y-axis. You need to say the x and y coordinate of your wedge and the mass properly. So what are my x coordinate and y coordinate of the wedge and the masses? For wedge it is very simple. This is a big mass M. So for wedge this is simple. The only variable is x1 and which is moving along x, and for y there is no motion. So your this x is x1 and no motion along y. Y के ऊपर थोड़ा ही जा रहा है ये, x के along जा रहा है. No motion along y. So for wedge the kinetic energy is half of mx dot square, which is eventually half of mx1 dot square. For the box, small mass m, this is wedge. Let's see for the box what happens with the box. Mass m, small mass. For this box, the x coordinate is, you will see, x1 plus x2 cos theta. Why is it so? For box, the height at a certain point of time, the height from the ground, this is box y of the box, and this is the x of the box. So for the box x, you will see this is x1 plus this distance, and if this is theta, if this is theta, this is also theta, so this is theta, so this is x1 and this is x2, so this is x2 cos theta, and obviously this is x2 sin theta. We will need it also. This is x2 sin theta. So this is x1 plus x2 cos theta is the x coordinate of that box. What is y coordinate of the box? Y is, you will see, y is how much? Y is the height h, this is height h minus x2 sin theta. This is height h. You subtract x2 sin theta from the height h, you will get the distance from the plane, from the ground of that box. So this y is h minus x2 sin theta. We are done by calculating the coordinate. Then the kinetic energy of the box, Ke of the box, half of m x dot square plus y dot square. You just make a derivative of this x and y. So what you will do is x dot is x1 dot plus x2 dot cos theta plus, no, not plus, this is done, theta is constant, and y dot is minus x2 dot sin theta. Make a square and do the addition. you will get half of m x1 dot square plus x2 dot square plus 2x1 dot x2 dot, sorry, there will be a cos theta. Yet cos square theta sin square theta will give you 1, and this 2x1 dot x2 dot cos theta will remain. What will be the potential energy, kinetic energy of the box? PE of the box. P of the wedge we won't take because this is not moving. P of the box is how much? Minus mg x2 sin theta. Why we will take so? We will take some reference. What we will take it your reference, that depends on you. So you could have take the reference potential energy 0 here or 0 here. So what my in this problem, say you take your reference frame u equals to 0 at the top, then you take how much downward distance it has traveled, and then you calculate potential energy for that downward distance. So what we will doing is we will making at this point, this line, this is your PE level equals to 0 along this line. So which is the top, this line. Well, then PE of the box in this notation, the displacement from the equilibrium point or displacement from the reference line where the potential energy is 0, the downward displacement is x2 sin theta. So the potential energy of the box will be minus mg x2 sin theta. Fantastic. So it is almost done. We will just add this kinetic energies of the wedge and the box and the potential energy of the box to get the Lagrangian. So what my Lagrangian is, so then the Lagrangian is first the potential kinetic energies of the boxes and wedges, this plus half of m. You see, you have calculated already the kinetic energy of the box. That was the kinetic energy of the wedge, the first part. The second part will be the kinetic energy of the box. The kinetic energy of the box is half of m x1 dot square plus x2 dot square plus 2x1 dot x2 dot cos theta, and we will subtract the kinetic potential energy here. Lagrangian, you know, L equals to T minus V. So we are subtracting, and the potential energy was itself was negative in our notation here. So we'll subtract the potential energy from here. So it will be this plus mgx2 sin theta. Fine. So we got the Lagrangian. So Lagrange's then we'll find the Lagrange's equation of motion. You know the Lagrange's equation. Lagrange's equation of motion. I just make you remember del L del Q dot ddt of minus del L del Q equals to 0 for each variables. So for x1 we have two variables. For x1 the Lagrange's equation is this ddt of del L del x1 dot equals to del L del x1. For this, what we'll get, del L del x1 dot is from here. There are three equations, three terms where you will get ddt of del L del x1 dot, and there are any term where you will get del x1 only? No. So we will calculate this. Del L del x1 dot is mx1 dot plus mx1 dot plus mx2 dot cos theta, and there is no del x1 explicit term, so there is no del L del x1. So from here we will get ddt of m, small m, if we write the small m first, say x1 dot plus x2 dot cos theta plus m x1 dot equals to 0. So this makes this quantity as a constant of motion. So this makes your mx1 dot plus mx1 dot plus x2 dot cos theta is a constant of motion. And for x2, what we will get? Del L, the equation is saying ddt of del L del x2 dot equals to del L del x2. Here we get del L del x2 dot is how many terms having x2? Two terms, this and this. So we get small m x2 dot plus m x1 dot cos theta, and we also get del L del x2. Here we will get something, this mg sin theta. So my equation will be ddt of this m will cancels everywhere, this and this and this and all terms. So this will be ddt of x2 plus x1 dot cos theta. There will be dot here also. This is g sin theta. So here will be another equation. So you will solve here x2 double dot plus x1 double dot cos theta equals to g sin theta, and from here you will be getting mx1 double dot plus mx2 double dot cos theta plus capital M x1 double dot equals to 0. So now we are having these two equations this and this. From these two equations you will be able to find x1 double dot and x2 double dot just algebraically. So you need to find your x1 double dot, x2 double dot, right, to finally solve the equation of motion. These are the equation of motion. This is one equation of motion, this is another equation of motion, but these are coupled. So you directly cannot solve x1 double dot and x2 double dot from these two equations. So from these two equations you need to find a simple plus 9, 10 algebra to find x1 double dot and x2 double dot separately. So these two can be solved, and this is your home task. I cannot do everything for you. So say this, from this 1 and 2 you get two things. I am writing in red so that you will be able to check the final result. So x1 double dot will be minus g sine theta cos theta by m plus m by m minus cos square theta. And your x2, I don't have much place in here, so let's see. And x2 double dot will be g sine theta by 1 minus m cos square theta by m plus m. So these two final results you need to just get from these two equations. If you are just wondering how to do, then it is not very tough. You just find this, say from this equation you get x1 double dot in terms of x2 double dot, then you replace x1 double dot here, you will get x2 double dot, or otherwise say you get x2 double dot from here in terms of x1 double dot, then you that x2 double dot you replace here. So do yourself, you need to just check, otherwise your knowledge and your efficiency will not improve. So you just check these two things and then let me know. My contact number is this, my email ID is this. You can always contact me, and you can also comment in the YouTube below. So well, that's fine. Thank you very much for watching this video totally. So I will be trying to come with some another problem again. Thank you very much.